10.7 section of the Thomas Calculus book. In the previous lecture, you have seen that how to derive a formula for area under a polar curve, and then how to use it for uh, to find the area under a polar curve. And we have done one example. And in the previous lecture, we have drawn a few graphs as well as how to find tangent line, equation of tangent line for a polar curve at a polar curve. And that procedure is very simple. So what we do, we just simply convert the polar equation into parametric equations with the parameter theta, and then simply use the same formula that we have used in our parametric tangent to the parametric curves. So continuing the same areas and lengths in polar coordinates, in today's lecture we will do some examples on areas and how to find, and we will derive a formula for how to find area between two polar curves, the area of a region bounded by two polar curves, and we will find the length of a polar curve as well. We have done this example. I ask you to do this by yourself, and then the exercise 2 is to be done by yourself. Now we are supposed to find the area of this shaded region, which is bounded by this curve, which is r is equal to f of theta, and this curve r is equal to g theta, and the line theta is equal to a, and this theta is equal to b. So what we are going to do, we will use the same formula. We will, if we find the area under this curve, that is r is equal to f of theta square, and subtract the area under the curve r is equal to g theta, then we will get this required region. So this is my formula, and simplifying it, I will get half a to b f of theta square minus g of theta square, and then d theta. That is, first we have to take the square of f of theta and g theta and then subtract it. First square and then subtract it. This is the formula to find the area of the region bounded by two polar curves. In this formula, this f of theta is the outer curve and g of theta is the inner curve. In Cartesian coordinate, we have taken f of x equal to the upper curve and g of x is the lower curve. But over here, the outer curve is this f of theta. This f of theta is the outer curve, for which this distance r is basically the distance of all the points of f of theta from pole is greater than for this curve, this r. So we will take f of theta to be outer curve, subtract lower curve, inner curve from the outer curve. So remember this point. Let's apply it to this example. Find the area of the region that lies inside the curve r is equal to 3 sine theta and outside the cardioid r is equal to 1 plus sine theta. So first of all, the first step to find this area is to draw these two curves. We should know that this r is equal to 3 sine theta is a circle that lies along y-axis, as I told you before, and the cardioid r is, and this r is equal to 1 plus sine theta is a cardioid along y-axis. So the area of this region, and then after drawing the two polar curves, we have to shade the required region whose area is to be calculated. So the required region lies inside the circle, inside this circle, and outside this cardioid, outside this cardioid. So this must be the area of the required region. Now we have to find the next step is to find the limits of theta. We have given the formula. The important thing over here is in such type of questions is to find the limits of theta. The theta is changing from this value to this value. So in the next step, we have to find the points of intersection of these two curves. And how to find points of intersection of the two curves? Yes, how to find point of intersection of the two curves?
Ma'am, simultaneously solve.
We solve these two equations simultaneously. That is, we put 1 plus sine theta is equal to 3 sine theta, or 2 sine theta is equal to 1. It means sine theta is equal to 1 over 2. It means theta lies in the first quadrant, first and second quadrant. Theta is equal to, this is 5 by 6, and in the second quadrant this is 5 pi by 6, and then we can find the corresponding values of r for this, but there is no need to find. Now area is equal to, required area is equal to 1 by 2 from pi by 6 to 5 pi by 6. The outer curve is 3 sine theta, 3 sine theta square. The inner curve is 1 plus sine theta square and d theta. Now simply open the square, simplify it, integrate it, and then put the limits. We can also use the limit, make use of the symmetry by taking the limit from pi by 6 to pi by 2. Pi by 6 to pi by 2. Over here. You can find the area of this region and then double it. Okay, simply find this and then double this 2 times of this. Make use of the half angle identity. Okay. So for such types of question, we need to find the points of intersection of the two curves. So how many points of intersection you can see in the figure? How many points of intersection do these curves have? Three. That is, where is the third one? Where is the third one?
Pole pe.
Origin or pole, but this pole is not seen in this after simultaneously solving these two equations. This pole is also a solution. This pole lies on this circle as well as on the cardioid. But this pole is not, does not appear in this equation. Why? What are the polar coordinates of this pole? This point, pole
0,
or
0.
origin? 0, 0. As I told you that r is equal to
बल्कि मैम
0 lies,
रेडियस 0 है, एंगल कुछ भी हो सकता
angle can, angle arbitrary. So let's see. So the fact that a single point has many representations in polar coordinates sometimes make it difficult to find all points of the intersection of two polar curves, because a single point has many representation. For example, pole has infinitely many representation. For example, 0, 0 can be a pole, 0 pi, 0 pi by 2, 0 3 pi by 2, 0 2 pi, 0 4 pi. These are all representation of the of origin or pole. But now we can see from the figure that the circle and this cardioid intersect at the pole. So when we draw the circle, we see that 0, 0 and 0 pi satisfies this curve, that is the circle. So these 2 points, which are the representation, which are the poles, lies on the circle. And similarly, 0, 3 pi by 2 lies on this circle because it satisfies this curve, this cardioid. but they do not appear in the simultaneously solution because these are not the simultaneously solution. These 3 points are not the simultaneously solution of these two curves. That's why they do not appear in the solution, simultaneously solution of these two curves, but they are the points of intersection of these two curves. 0, 0, 0 pi, 0, 3 pi by 2 do not simultaneously satisfy r is equal to 1 plus sine theta and r is equal to 3 sine theta, but they are the point of intersection of the curve. So it means to find the point of intersection of two curves, we have to draw the two curves. That is, to find all points of intersection of two polar curves, it is recommended that you draw the graphs of both the curves. This is not the case for a pole only. It can be case for other points as well, as you will see in this example. Find all points of intersection of the curves r is equal to cos 2 theta and r is equal to 1 by 2. So what is the graph of r is equal to cos 2 theta? क्या है ग्राफ इसका? R is equal to cos 2 theta. We have sketched this graph. It is a four petal rose. Yes, just like this. Like this. And what is the distance of this point? Radius or R is 1. So this is less than equal to 1. So this maximum distance is 1. And this R is equal to 1 by 2.
Circle with radius 1 by 2.
With radius 1 by 2 and center at the pole. So how many point of intersection? This point, 2,
8.
3, 4, 5, 6, 7, 8. So we have 8 points of intersection. So to find the points of intersection, we need to simultaneously solve this equation. Cos of 2 theta is equal to 1 by 2. It means this 2 theta lies in the first and fourth quadrant. That is 2 theta is equal to first quadrant, fourth quadrant, and then we will add 2 pi in both of these because then we have to divide it by 2. After dividing it by 2, these are the 4 points of intersection. You can find the values of r as well. But as we have seen that by drawing the graph of these two polar curves, that these two, there are 8 points. So where are the rest of the 4 points? How will you determine the rest of the 4 points?
R is equal to minus 1 by 2 भी हो सकता है.
Yes, it can be r is equal to minus 1 by 2 because r is equal to minus 1 by 2 is represented by the same circle this. Yes. So we will solve 2 theta is equal to minus 1 by 2. Simultaneously r is equal to cos 2 theta and r is equal to minus 1 by 2. Simultaneously solve it. And after solving that, we get the rest of the 4 points. Which are pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. So it means in finding the points of intersection, you first need to sketch the graphs and then find a point of intersection. Okay. Let's move to the next example, which is calculate the area of the region outside r is equal to 2 plus 2 sine theta. Inside r is equal to 2 plus 2 cos theta. And in the first quadrant. What type of curves are represented by this? R is equal to 2 plus 2 sine theta. What type of curve is this?
Cardioid.
It's the cardioid which lies along the positive y-axis. And what about r is equal to 2 plus 2 cos theta? A is equal to b, so it is also a cardioid that lies along the polar axis, the x-axis. So its graph is like this shape. So what is the required region? Now we have, after drawing the graphs, we have to shade the required region. This is r is equal to 2 plus 2 sine theta. This is r is equal to 2 plus 2 cos theta. Outside this curve, 2 plus 2 sine theta, and inside, but in the first quadrant, it means this should be the required region. Outside this 2 plus 2 sine theta and inside 2 plus 2 cos theta, but it should lie in the first quadrant. So what would be the values of theta? So my outer curve is 2 plus 2 cos theta. Inner curve is 2 plus 2 sine theta. And the values of theta are. Now we have to find the limits of theta. So the theta is changing from this to this. This is my outer curve. This is my inner curve, 2 plus 2 cos theta. So the values of theta are from theta is equal to 0 to this point of intersection. That is, we have to simultaneously solve these two equations. I will get tan theta is equal to 1, theta is equal to pi by 4. That is limits from 0 to pi by 4. Okay. The limits of theta are from 0 to pi by 4. This is the required region. For the points of intersection, you have to solve it. Theta is equal to pi by 4. Outer curve is this, and this is my inner curve. Okay. Is there any confusion in this question?
No, ma'am.
This question. This is how you will find the area of the required region. First, draw. Then find the point of intersection. And then find the limits of, shade the required region. Find the points of intersection. Then find the limits of the integration and then integrate. Use the formula to integrate. Okay. Whether you are asked to find the to sketch the region or not, you are supposed to sketch the region first. आपको क्वेश्चन में एक्सप्लिसिटली ये मेंशन हो या ना हो कि आपने sketch करना है या नहीं, but you have to sketch, otherwise your question you will get a wrong answer. Now let's move further and see how to find the arc length. So to find the arc length of a polar curve, we will make use of this formula, that is dr. We have this dr over dt that we have used for parametric curve. This is the formula that we have used to find the length of a parametric curve, represented by with the parameter theta. Over here we can convert this polar curve r is equal to f of theta into parametric equations by using x is equal to r cos theta and y is equal to r sin theta, and instead of that we will now use dr over d theta, dr over d theta whole square, and then d theta. We can further simplify this expression, the expression inside the square root, that is this. This is dx. We can further simplify this expression by putting the values, and we get this value. So we will just go through these two things. I will skip these two things. These are just calculations. So after simplifying it, I will get this r square plus dr over d theta whole square. Okay. This is the formula that we will be using to find the length of a polar curve. Okay. Find the length of the cardioid r is equal to 1 plus sine theta. So the first step is to draw this cardioid r is equal to 1 plus sine theta. Since we have sketched this curve in section 10.6 in example 2, and in that sketching you have seen that this curve is sketched when we take the values of theta from 0 to this value 0 to 2 pi. So the limits of theta are from 0 to 2 pi r square, and this would be the integrand. Simply put r equal to this and dr over d theta is equal to this, and then integrate it. I will solve this example for you. Find the arc length of half of the loop inside r is equal to 1 plus 2 cos theta. Now this is a lemma-son with a inner loop. So let's draw it, and for this we can draw it by two ways: by plotting the points, taking different values of theta and then calculating the corresponding values of r and then plotting the points r theta. And we can also sketch it by the second method, which is by sketching the given curve in Cartesian coordinates and then sketch it in the polar coordinates. The second method is useful when we have more dimples and more loops in our graph. The graphs and the loops and dimples can be shown more easily if we use the method too. So, but for this, since it's a lemma-son, and for this we can draw it easily if we plot the points, that is taking different values of theta. And I will start with the values of theta equal to 0 and taking a gap of pi by 6, and then pi by 3, pi by 2. And what comes next? This is actually 3 pi by 6, then 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6, 12 pi by 6, which is 2 pi. Okay, समझ आ रही है या नहीं आ रही? Okay, now calculate these values of the corresponding values of r.
Excuse me, ma'am.
जी
मैम cos theta is symmetric about polar axis, तो हम पाई तक सिर्फ कैलकुलेट कर सकते हैं.
जी कर सकते, लेकिन इधर वही हम करेंगे, पाई तक ही करेंगे, उसको फिर कर लेंगे. ये बेसिकली मैं सिर्फ आपको लिमिट्स दिखा रही हूँ, सिर्फ पाई तक ही करेंगे इसको. बेसिकली मैं थोड़ी सी लिमिट्स दिखाना चाह रही थी.
अगर हम sin थीटा वो लाइन पाई ओवर 2 के सिमेट्रिक है, तो 0 से पाई ओवर 2 तक अपर
माइनस पाई बाय 2 से पाई बाय 2 तक कर लें.
माइनस पाई बाय 2 से पाई बाय 2, तो फिर वो उस तरफ इन्वर्ट कर लेंगे दूसरी तरफ.
बेसिकली आप जब ड्रॉ करते जाएंगे आप देखते जाएंगे कि कहाँ से वो जितना कर्व उधर बन रहा है वही आप उधर ड्रॉ कर लें. ठीक है, तो कुछ देख के भी पता चल जाता है कि कितनी लिमिट्स लेनी है आपने. फिलहाल मैं तो आपको सिर्फ ये बता रही हूँ कि ये मैंने तो सारी ले ली. ओके, व्हाट इज द वैल्यू ऑफ r व्हेन थीटा इज 0? इट इज 3 पाई बाय 6 पे √3. नो, इट इज जल्दी जल्दी बताएं.
2.8 something. 2.8.
2.8 है जी. व्हाट अबाउट पाई बाय 3? 60 degree. 2. What about pi by 2? It is 1. What about 2 pi by 3?
2 pi by 3.
0. What about 5 pi by 6?
5
What about 5?
0. Should be 0.
J?
0.
0. 2 pi by 3 पे तो 0 आ गई. 5 pi by 6 पे क्या है?
इसमें भी 0 आ रही है
5/6 पे तो नहीं 0 आ रही.
-0.732.
Minus 0.7. What about 7/6? जी बेटा जल्दी कर लें, टाइम कम है हमारे पास. 7/6 पे बताएं और 4/3 पे बता दें, बस यही बता दें.
Be -0.7.
ये 0.7 है और इस पे 0 आ रही है, ये एक दफा कंफर्म कर लें. 4/3 पे देखें 0 आ रही है कि नहीं आ रही.
यस मैम 4/3 पे 0 है
चलें जी ड्राइंग करते हैं पहले. स्केचिंग 0 पे. When theta is 0, the value of r is 3. When theta is pi/6, it is 2.8, lies somewhere over here, and then 2, r is decreasing, and then pi/2, it is equal to 1. So it is decreasing in this way. This way. ये थी. अब आपने गौर करना है सब ने, जितने भी बैठे हुए स्टूडेंट सब जरा गौर करें. सबकी नजरें यहाँ होनी चाहिए. मैंने कैसे लिमिट ली है. थीटा इज चेंजिंग फ्रॉम 0 to pi/2. r is changing from 0 to 3 to 1. And then at 2/3 it is 0. So the curve is like this. We can also take some value theta between pi/2 and 2/3 and we will get the values over here. No, the negative values. 5/6 is equal to -0.7. 5/6 lies in the second quadrant. So in the opposite of 5/6, I will get some values over here. At pi, it is equal to -1. This is my theta is equal to pi. So I will draw it in the opposite direction. This is my pi. So I will get the inner loop, this. So it means the outside half loop is drawn when we take the values of theta from 0 to this. And what is the value of theta from 0 to this? थोड़ा सा मैंने ये the upper loop is drawn when theta is taken from 0 to at this point, that is 2/3. This point is 2/3. The lower half loop is drawn when theta is from 2/3 to this pi changing. And the upper half loop is drawn when theta is from pi to 4/3. Again, we will get. And the lower outer loop is drawn when theta is from 4/3 to 2 pi. Okay. Now you can find the length of any loop, any curve of this. For example, if I want to find the length of half of the inside loop, so it is equal to what? The values of theta is, I can take the limits from 2/3 to pi or pi to 4/3. So I will take the limits from 2/3 to pi, because स्केचिंग के दौरान मैंने देखा कि ये इनर लूप जो लोअर लूप है, इनसाइड लूप इज ड्रॉन व्हेन थीटा इज चेंजिंग फ्रॉम 2/3 to pi, and the rest of the formula remains the same, d theta. This is for the half of inside loop. And if I am supposed to find the length of the complete inside loop, so what would be the limits? These students, what would be the limits if I have to find the length of the inside loop?
मैम 2/3 से 4/3 तक.
Yes, 2/3 to 4/3, or we can take it from 2/3 to pi and then double it 2 times this. And what about the if I'm supposed to find the half of the outside loop, half of the outside loop, what would be the limits of the, when I have to find the half of the outside loop?
0 से 2 pi by 3.
0 to 2 pi over 3. And if I am, what about the lower loop or the complete, the outer loop, not the half but the
इसी को
complete?
2 से मल्टीप्लाई कर लें.
2 से मल्टीप्लाई कर लें, और अगर मैं 2 से मल्टीप्लाई ना करूँ तो वैसे फिर क्या लिमिट्स बनेंगी? फिर क्या बनेंगे? आउटर
फिर
लूप बन
मैम
रहा है
इस ये ऊपर
0
वाली
से
जो है ना 4 पाई बाई
0 से
3 से
2
2
पाई
पाई
बाय 3, 0 से 2 पाई बाय 3 तो अपर बन रहा है, और लोअर कब बन रहा है? जब ये
4 पाई बाई 3 से
यस 4
2
पाई
पाई.
बाय 3 से 2 पाई, ठीक है ना? बाकी आपके पास वही चीज आ जाएगी. दिस इज हाउ यू विल फाइंड द लिमिट्स. बगैर स्केचिंग के आपको लिमिट्स का नहीं पता चला, तो यू मस्ट ड्रॉ द sketch the curve first and then find the limits of theta. जी किसी को कोई confusion इसमें? ये बाकी सारा हुआ है. See the integration. Any confusion in this question? Okay, students, you need to do these practice questions. I will upload an assignment on MS Teams on these topics. I think we have done this section, parametric curves and polar coordinates, and in the next class we will inshallah start a new section which is on sequences and series, infinite sequences and series. Okay ji, any confusion in this question? Please tell me right now so I can.
Excuse me, ma'am.
Yes.
मैम जब हम एरिया फाइंड करते हैं पोलर एक्सिस के नीचे वाला, तो उसे हम नेगेटिव लेंगे जिस तरह से
नहीं
हम
नहीं,
उसे
नेगेटिव नहीं, उसमें
ordinary-
नेगेटिव पॉजिटिव नहीं होगा, इसमें नेगेटिव पॉजिटिव नहीं होगा. ठीक है, इसमें आर को नेगेटिव पॉजिटिव तो आपने देखा था ना कि जो थीटा के ऑपोजिट अगर आप ड्रॉ करेंगे तो आर नेगेटिव होगा. इसमें वो नहीं, हम इस चीज में नहीं हम कॉन्स्टेंट. नीचे आ रहा है, ऊपर आ रहा है, जिधर भी आ रहा है आपका ए जो है वो जैसे जो मेथड मैंने बताया उस तरीके से करें.
एक्चुअली मैं
जी
वो जो हमने स्टार्ट में एरिया कैलकुलेट किया था तो उसमें हमारे पास इक्वेशन से 2 पॉइंट ऑफ इंटरसेक्शन आ रहे थे. तो हमने जो इक्वेशन से पॉइंट ऑफ इंटरसेक्शन है उसी के अकॉर्डिंग एरिया कैलकुलेट करना है, या जो ग्राफ से हमें व्यू आएंगे?
ये तो डिपेंड करता है ना कि हमें कौन सा वाला पॉइंट चाहिए. अगर तो वो पॉइंट ऑफ इंटरसेक्शन, अगर तो ये पॉइंट ऑफ इंटरसेक्शन आपका ग्राफ से आ रहा है तो फिर आपका पॉइंट ऑफ साइमल्टेनियसली सॉल्यूशन से नहीं करेंगे. ये तो हमें साइमल्टेनियसली सॉल्यूशन से मिल गया था ना, लेकिन स्केचिंग से पता चला कि ये कौन सा पॉइंट है. ये तो डिपेंड करता है कि आपको वो पॉइंट ग्राफ से मिल रहा है या आपको वो पॉइंट, जैसे कि अगर हम ये देखें, ये पॉइंट अगर आपसे ये कहा जाए कि ये एरिया फाइंड करें, दिस एरिया, ठीक है, ये वाला, तो ये आपने देखना है कि ये साइमल्टेनियसली सॉल्यूशन से आ रहा है या ग्राफ से आ रहा है. ग्राफ से तो सारे मिल जाएंगे, लेकिन साइमल्टेनियसली सॉल्यूशन से आपको कम मिलेंगे पॉइंट्स. देखिए ये एरिया भी है, ये एरिया भी तो है. ये एरिया कैसे फाइंड करेंगे? चलें बताएं जल्दी से.
5/6 से 5/3.
लेकिन ये आउटर कर्व कौन सा है, इनर कर्व कौन सा है? आउटर कर्व कौन सा? r is equal to 1/2. इनर कर्व है, इनर कर्व r is equal to cos 2 theta.
यस मैम.
ये आउटर है, ये आउटर है और ये इनर. एंड लिमिट्स ऑफ थीटा इज फ्रॉम π/6 to π/3. ठीक है, तो कुछ पॉइंट इस पे आपको स्केचिंग से मिले और कुछ पॉइंट आपको पॉइंट ऑफ इंटरसेक्शन से मिल गया. तो एक स्टूडेंट ने पिछली क्लास में क्वेश्चन किया था कि व्हाट इफ इट इज नॉट गिवन if we have to find the length of this curve, theta is equal to pi. It's not mentioned explicitly in terms of r, because over here r is not mentioned explicitly. अगर यही curve हो theta की terms में curve given हो, theta is equal to pi. So theta is equal to pi is what it is polar axis. It is a straight line polar axis, and since this polar axis, this is a line, and the length of this line is infinite unless we specify the limits of r, that is it lies from 0 to 1 by 2. So r is 0 to 1 by 2. So the length of this curve is from 0 to is 1 by 2 simply. That was the question that was asked in the the class lecture with the B section. That if we have given this curve theta is equal to pi and we have to find the area length of this curve, then obviously this curve theta is equal to pi is a straight line. This is a trivial case. This straight line, that is the x-axis, and the x-axis is of infinite length unless we are given the limits of r, and limits of the if the limits of r are also given, that is from 0 to 1 by 2. So obviously this we don't make use of the formula for the length of the curve. So the length is 1 by 2 in this case. Okay. Any question? Yes, students, any question related to it?
No, ma'am.
Okay, Jay, I will see you in the next class then. Allah
Excuse
Hafiz.
me, ma'am.
Yes.
Ma'am, मेरी attendance